One of the other things we tackled yesterday was the concept of a domain and range, and the idea that the domain is the set of input values into the function, and that the range was the set of output values of the function. And so an ordered pair really is a number from the domain paired with a number from the range, and that pairing is often determined by a rule. Okay, so another bit of a language warning. So I'm going to go to our textbook, and I am on page 73. Up on the screen if you want to see it. So on page 73, it talks about different notations. Now, from what I understand in the IB course, they're not too formal on the notation, but the notation used in the textbook is one of these things here. So we've got this set notation here, which is, we use curly brackets here to show that this is a set of numbers, and this is the set of the numbers x. That vertical bar means such that, and then you've got x greater than or equal to 3. This is not how I would call interval notation, but anyway, I might come back to that. I talked about it last lesson. I'll go back to it in a second. Their use of inequalities is what they're calling interval notation, which I don't like so much. So they would say you could just write x is greater than or equal to 3 to mean the same thing. And this is the thing I really wanted to focus on. Have a look at that. It's a line, and there's a filled-in circle at the start. That means everything from 3 inclusive of 3. This one here is the set of values of x such that x is less than 2, or just the x less than 2 bit. And you can see there's an open circle there. So that open circle means everything from 2 but not including 2. This one here is -2 to 1, not including -2 but including 1. That's what it looks like using your inequality signs. That's what it looks like using set notation. The set of values x that are generated by looking at all values between -2 and 1 inclusive of 1. And then this one here is 2 separate sets of numbers effectively. So this means x is less than or equal to 0, that's what that would be, and x is greater than 4, which would be all those numbers from there as a number line graph. Most importantly though, for what we're doing next, a solid circle means the number's included, an open circle means it's not. Now I'm going to do something naughty here for the video, and that is I'm going to do the notation on the whiteboard. So just looking at that one there, which is -2, x is between -2 and 1. The way I would write it in the interval notation that I showed you last lesson is that I would say it's between -2 and 1. It doesn't include -2, so I'll put a round bracket before the -2, comma 1, and then a square bracket to say that 1 is inclusive. So that's how you would write it in interval notation, and you would say that x belongs to, x is a member of that. Okay, so that's how you would write it using interval notation. Interval notation isn't always pretty, but for the basic cases at least, it does work fairly well. Okay, so what you're going to be given in the next exercise, we've got about 15 minutes left, is a bunch of graphs, and you need to work out what the domain and range is. So let's have a look at this example here. This one here has a domain where whatever number I input here, I am going to get an output. We kind of looked at an example of this last time. So that means that the domain is x belongs to the real set. It means that x could be any number at all. Okay? However, the range, it has a maximum at 2, 1, which means that anything above 1, the graph would not hit. So if I pick a value of y above 1 and draw a line across this way, it will not hit the graph. So it is not part of the range. And so we would say that the range is y less than or equal to 1. Or you could write y is a member of the real set, comma, y less than or equal to 1. That would be fine as well. You could also write y is a member of negative infinity, comma, 1 square bracket. So all those notations would be fine. Okay, so there's another example here. This example here is what we call a hyperbolic function or rational function. It means that this line goes towards this vertical line here, and the blue line goes towards the horizontal line but doesn't cross it. So x equals 2, the blue line never touches, and y equals 1, the blue line never touches. And so you've got this sort of notation. You're saying x is a member of all real numbers, but x can't equal 2. Y is a member of all real numbers, but y cannot equal 1. Okay. So to fully describe a function, we need both the rule and domain. So what you've got in exercise 3C is some intervals and some values that you need to graph, or you are given a graph like this one here, and you need to do, you know what, I don't think it will do questions 1 and 2. Let's just start off with question 3, and I want you to take these graphs here, and I want you to write down the domain and range based upon what you can see. So do that, and I reckon if you can move on from question 3 to question 4, great. But if you can at least do question 3 before 10:35, that would be awesome. And I'll leave this video here.